our next presenter is the Data and Insight Director at First Utility, and he will tell us about his experience of putting data science in several businesses. Everyone, please welcome Abed Ajraou.
Thank you very much. So, I'm Data Insight Director in First Utility, so I will try to do a little bit different keynotes right now. It will be very practical, and I hope you will enjoy that. So, I saw in data science fair a lot of issues, a lot of problems. So I tried to explain some big tips we've done in First Utilities, how to avoid these big mistakes, and I will try to give very practical example, and I hope you will enjoy that. If you have some questions, my session is very long, so I hope I will not spend too much time on explaining, but I will be careful about the time. I don't know where is the timer anyway. It's over there. Okay, let's start. So first of all, who knows First Utility? Great, that means all of you. There is only 2, 3 who knows First Utility, so that means you are paying too much on the energy, guys. You can save money by switching in energy. I'm not joking, it's true. Go to USwitch right now, you will see your brand. Easy to switch, go and make some money. So these big tips of this conference, you can save money, that's great. So it's not just that, we are also try to put a very great service, so we have very proud of that. We are on the energy market who put the best service, and also this is also my part, give you a lot of knowledge on your usage and give you a lot of knowledge in the energy, in your usage. I think the thing changed a little bit. Anyway, I will select like that. Okay, so let's talk about data science now. So data science is quite a very complex subject. I like these lines from Gartner, who try to define data science, and data science, we see, is a part of the business, is a part of the IT. I like the talk just an hour ago about the fact that data science needs IT people, and you will see how we've done that in First Utility. Not the same way, but very efficient. So you see data science has his own capabilities. However, it linked to a lot of things. And there is a mix and there is interactions. Like, for instance, good questions, like in high performance infrastructure. This is very needed to do a data science right now in your day age. And I will try to explain how we did that in First Utility. So I will try to split this talk in 3 different parts. So the first one is the right technology. So I saw a lot of companies trying to do something very, I would say, scary and not efficient anyway. So as you heard this morning, data science is also seen as only a business component, and they need IT people to help them availability to give them a space in the IT to make it fast their model. Why? Guys. So in First Utility, we did the other round. We put the data science team with the data team, and they are working together in the same platform. So people said in data science, no, we don't use Hadoop, we don't want that, we want to use Scala, it's better, it's Spark, it's so fast. Same. We can build a data lake that we enable Spark and enable BI people during the same platform. That's enable everyone use the same data set, enable everyone use the same technology, everyone will use a very fast IT platform. So that's what we build in First Utility. So we have a data insight platform, and we got all the data around. So the energy market is quite a long story. I don't want to go into details. So we have industry data, which is very good in data quality. It's a joke. And we have 3 parts on the data insight platform. So we covered data in operational way, and we covered data for dashboarding, so mostly BI area. And we also support data for predictive analytics. All that in the same platform. That's enable deliver the right service, that's enable optimize the business, and that's enable to give more knowledge to our customers. And we put the customers every time in what we do in the IT side. So it's deliver business value in a client. That means people are always, so a lot of companies think that data science should be part of the business. Agree. But I think that they need, as you heard, they need the IT area. So I don't believe my role is only in IT. I don't believe my role is only in business. My role is cross, and we need to have these two sides. And it's very efficient to bring the two in the same area. So how it looks like our IT platform. So we use Hadoop heavily. So again, people just say, oh, Spark will replace Hadoop. You probably heard that, probably read some article like that, very confusing. It's not true. Spark is replacing MapReduce. Hadoop will still live, and Hadoop is a big environment. So we are using HDFS, we are using Spark, we are using also Parquet format Cloudera with Impala, and we are now starting to use Kudu, which enable the right dashboarding in top, and we are using also Data IQ in top of Hadoop to have the capability, the predictive analytics capabilities. So that enables a better agility, that provide the right environment to everyone, also data warehousing and a data lake, enable data discovery, we can collect more data, etc. So this is the first big thing to get better efficiency in data science. Data science is so much often, and sometimes people we hide in our team, people say, oh, Abed, I want to get all the data. I want my server collect all the data, and I will map predictive analytics on top of it. Why you reinvent the wheel? There is a team already process the data. They are better in that. They are better in data quality. So why you want to reinvent the wheel? You have already a data lake that is store all of that. You just spend your time more in your skills in predictive analytics rather than try to collect data, modelize the data, think about data quality behind. So you heard about this thing about data scientists spending 70, 80% of the time just to modelize the data and deal with the data quality errors. So in my team, no, data scientists spend 80% of the time in predictive analytics, which is more efficient. So the second thing is, thing that I fall again, we talk about this morning, which is great, is I call it the right mindset. So we talk about this morning about start with the problem first rather than the data. When you said that, it's obvious, very obvious. We start with the problem, start with the question, and we want to resolve the question with the data. It's not that obvious sometimes because people like to do something and try to do some cool model, use the data and see what's happened. Okay, I will bring an example. I don't like to mention names of companies, but this one is, I need to mention it. Who works in Barclays? No one? Okay, so I can say it. So in the last Hadoop, Strata Hadoop meeting, there is this conference in Barclays. Very, very nice, honestly, very nice technical conference about Spark and Graph. So what they did, they tried to see all the payment card and see which business is closer to the other business. It's great. So that give, okay, this McDonald's is close to Sainsbury, etc., and how to map that with Spark and technology. It's fantastic talk. At the end, he asked a question. If you have an idea how I can use that, because we don't know what to do with. What? So, and this is a common mistake. People just honestly realize that, okay, we got a lot of lights in data science right now, lot of buzz thing, lot of money coming, lot of investment. We should not discredit this project, please. We should not spend money on a project where we don't know where to go. I don't say we need to have the answer before starting. It's not my saying. My saying is exactly what she said an hour ago. We need to have at least a question what we want to optimize. That's the first step. Otherwise, you will waste money and time, and that's not good for us who are data professionals. The first big thing is the right methodology. That's make me sometimes, honestly, I saw a lot of projects taking long time. So we talked this morning about agility. It's part of that. There is some people who are we saw that a lot of data scientists are so proud of the work, so meticulous, and don't want to release a work if it's not perfect. So we have a lot of data scientists who are perfectionists. That's good, but we need to have the right methodology. So I saw a lot of projects taking 3, 4, 5 months, which is too long. So the first step is explore the data. So we have a lot of, obviously, the first step is to see the data, see what's happened, see the trend, explore the data. This is a lot of work that's done by data analyst people. However, data scientists are also doing that often. That's good to visualize the data, to see the trend. That gives a way to say, OK, this data is quite useful. I will try to use it in my model. The second step, I will not spend too much time in this slide, because the next slide we try to a little bit contradict this slide, is take the time of feature engineering. So feature engineering basically is to change a little bit the data to make my machine understanding better and to make my machine learning quicker. For instance, this man won the first prize in the competition just by grouping some colors which make sense, but if you see the data, it's not that obvious. So he grouped the little bit the color that's not unusual, and making together increase the accuracy of his model and get the first prize. So I saw a lot of data scientists spending hours and hours and hours trying to find the right combination to make the machine better. However, there is a trend now, and now we're going at the stage where the model is able to find the right feature and the right combination of feature. So the last 2 years, an hour and a half, there is a big trend now coming, all the Kagglers in the competition. Everyone know what is Kaggle? Yeah? Kaggle competition? Okay. All the Kagglers now using XGBoost, which is better now than neural networks and random forest. So XGBoost is the family of gradient booster. So boosting model is something very interesting, and there is the Dr. Tianqi Chen who did extreme gradient booster. He makes it better and faster. So that's why I bring that, because honestly, I just want to explain to you, it's not, if people are afraid of data science, afraid of mathematics, honestly, you should not, because it's quite very easy to explain. So I will try to do that. So boosting is very interesting model to understand. So every data scientist, he tries to predict a subject. So you have a variable y to predict. And he tried to find a model with all the features he's got to predict this feature y. And all the features he got is x. So he tried to find a model to predict y, and obviously he got an error. This is what random forest neural network tried to do to predict y. The boosting model is going faster, is going better. So they say, OK, this error is not necessarily completely an error. It's not what you saw white noise. Maybe there is another model I can use a little bit to predict y. So this error, that's why it's doing boosting. This error is also another model I will call n, and with another error, error 2. So it's a combination of different models. It tries to find which combination is the best. And error 2 is the same. It could be another model. NL, for instance, another model, plus another error, etc., etc., etc. So after that, obviously, it's not linear. So at the end, it tried to find all the combination with different things. So it could alpha m plus beta, constant n, x, plus gamma l, etc., etc. So this kind of model quite existed for a long time. However, the problem of that is trying to overfit. Because we try to be better and better and better, more accurate, more accurate, more accurate. And the problem is that when you're going to be more accurate, it's going to be too much specific. So is getting to be overfit. That's extreme gradient booster is doing, is try to avoid this overfitting. And also use the parallel and try to use faster the new technology and try to be faster than what it's doing. So that's why extreme gradient booster now, XGBoost is a new trend and everyone is using. I saw companies only using that because it's fast, it's accurate, it's doing my job. Why I should spend time on feature engineering like what we've done 5 years ago, spending time to increase my accuracy for 1%? I don't mind. Now I got that. Thank you for this doctor who did that. And now a lot of companies are using that directly, and it's giving my result. OK, it's not that simple because overfitting, how we can avoid the overfitting? Cross-validation. So it's part of the methodology you need to have. So I saw a lot of citizen data scientists just don't do that. That's a big mistake. We have to make sure that your model is not overfitting, is not completely. We need to make sure that it could be very accurate in the first step. But if you don't cross-validate your model by this technique, you probably make it too much specific in your data set. So cross-validation is also part of the XGBoost. It's very simple to use, and make sure that you make sure that your model is very, very good. Feedback loop is also something that is missing in much of the project in data science. So think about machine learning is not a software, bit of software. I created, it will work. No, the data will change. So for me, machine learning, a model, is like a baby. You don't let your baby for 3-4 days without any care. No, you need to care it. You need to be proud of your baby and feed it and make sure that it's working well. So feedback loop is very, very, very important. Make sure that your model is still running, your model is still accurate, etc. And I saw a lot of projects completely missing this part. Letting 2 years running, and after that, oh my God, it's not that accurate anymore. So the problem is that I saw a lot of projects like that and try to be very good and try to loop and see, oh, I do that, oh, I come back, and oh, no, I need to see the feature engineering, oh, no, I tried another model, oh, I see a lot of data, oh, I have new data, I will fit. Come, stop. It takes too long. We need to be, we are in a business. I'm here to talk about my feedbacks. I'm working for a business that is, I not sell any project. I didn't sell any software. I'm here to say you that the money we are investing in this project is a time that the company invests to us. So we need to be conscious of the time. We need to be faster, even if it's not perfect. But we need to deliver something. So in Firstity now we are working on sprints and make it fast. We know that the first version is never completely good. However, we have a first thing to show, the first version to publish and to make sure that people can start to use it. So Another thing that sometimes you saw something that, oh, I saw it 5 years ago, 10 years ago. So do you remember if some people work in BI side or data analytics, so we went on the stage of coding to the ETL. So we were that, oh, we get better and faster and the efficiency of the team is increased by having more visual rather than coding. So I saw that in a lot of data scientists, they lack coding. You have a lot of codes, and after that is very hard to peer review, it's very hard to take over, etc., etc., etc. So that's why one of my favorite app is Data IQ. It's enable this kind of thing to get a team more efficient. So all this methodology part is part of the tool, and also you have this Data IQ flow where we see visually what's happened, which data, which feature you're using, which model you're using, and all the steps of your project, and it's enabled collaboration. People can work in the same project. So for me, okay, there is some data scientists say, oh no, I want still to code in R, I want still to code in Python. Great! This tool also enables to code in Python and R. However, we need to be more efficient anyway. So when you collaborate, when you do some peer review and handover, it's good to have some visual, it's quicker, it's better to make your team more efficient. And my last, I think I'm running time, my last comment is data science is nothing about, we need a team. It's hard to have someone, I would say impossible, to have someone who have all the knowledge on the data science sphere. You can't have someone who is very good in IT, someone who knows the business very well, who communicate very well, etc., etc., etc. So I found this tool very interesting if you want to use it. It's quite minimum, but it's very good. It's called strata.com, if you can see it. So this is the map I've done with my team. So you can see where is their strengths and where they are not good at. And that's good because this is a way to see if your team is have a good, so if you map all the skills in your team and make sure that they are all working together. So we have strong modelers, we have strong communicators, strong technologists, but it's quite impossible to have one who has all the skills together. So that's why data science is nothing without a team. That's my last comment. Thank you very much. If you have any questions.
Thanks, Abed. Many utility companies use SAP. Do you guys use SAP?
No, I'm completely not a fan of SAP.
Okay.
If First City have SAP in the first place, I joined First City 2 years ago. I will never join them.
Okay.
For one big reason, honestly, let's talk about this just to answer the question. Why I hate SAP myself, not my company, but myself. I know my CEO hate them also. Anyway, SAP is, they have this concept, let's talk about the big data sphere. SAP has this concept of everyone should have SAP. So for them, SAP is SAP HANA. SAP HANA is only one component of the big data. It's only the memory side, NoSQL engine on memory. This is what we call Parquet format and use Impala in the Hadoop sphere. But big data is more than that. So I asked people in SAP in a big data conference in Paris, said them, okay, how do you handle non-structured data? How do you handle all the talk you just 30 minutes ago about unstructured data? This is big data. So how we will use some people in my team about NLP, where we use all the unstructured data to get some more insight in there. Don't need. Everyone should have SAP. Everything is structured for their word. So no, we don't use SAP. I don't want to use SAP.
Thank you. I don't work for SAP. The reason I ask is that we have many clients who use fundamentally SAP, particularly in the energy and manufacturing sectors. But obviously, I see very much a need, if they are using that, for other tools, for exactly the reason you mentioned, if nothing else. For HANA is fundamentally a relational database in memory and cannot deal with structured data, unstructured data, sorry. So, interesting. Thank you.
Welcome. Any other question? Yeah.
Can you talk a bit more about XGBoost and are there any other pitfalls to using it other than overfitting?
So about XGBoost, so this is a trend. So a lot of Kaglers now only use that, which is great. So we need also to not be, all the methodology should be there. So make sure that it's not overfitting, etc., etc. However, there is a one trend is going better. So that's why people, when I say to my team, don't think that you will stop learning here. Every year you will learn something new, and that's make this area very fascinating. There's one area that is going in research that is not well integrated in XGBoost is predicting time series model. So it's very early stage. So there is one who published in the GitHub their code combining XGBoost with a time series problem. It's very early stage. For this reason, we are not using XGBoost in this context. But I'm pretty sure that it will be soon, very soon. But that's the technology watch. We need to also be aware of what's happened and take time to see what's the best thing to do. For me, it's just about efficiency. Why the point to spend hours in feature engineering when we have a model and it do better in the first place? When I did, for instance, in my team, I did also a tutorial video about XGBoost, how to use it. There is also a way to optimize XGBoost. It's not that, okay, just create XGBoost and it works. No, we have also a way to optimize it, especially when the data is not, there is a skew in the data. So when you go to trend data and you try to predict, you don't have a lot of cases. So this kind of thing, XGBoost is also good for that. So it can help you to equilibrate a little bit the data. But that needs a little bit tuning. But otherwise, it's running well. Yep.
Hi. How is smart meter data changing the industry for you?
Could you repeat the question?
Smart meter data?
Smart metadata, yes.
Yeah, are you
So what's the
working with
question?
that? How is it? Does it have any implications for your industry, and are there any interesting findings?
Not really, I would say. So smart metadata is very good in terms of understanding the usage of it. But anyway, that has been done a long time ago. So just for information in the energy market, so if you see a lot of suppliers pushing you to have a smart meters, is only because the government pushed us to have smart meters. In terms of data, all the profiling of the consumption, we already know that for a long time. We know how the customers are using the energy and at the day level. So we know on Monday and Tuesday is not the same. That's known for a long time. What smart metadata will give us, now we have a subject to try to estimate better the usage for the customers who don't have smart meters by using smart meters data. This kind of subject that only make the accuracy for the customers better. So people who don't have smart meters, sometimes they're frustrated. They went on holiday for a month. They come back. They have this invoice. Oh, I never consumed that high. Yeah, you were on holiday. You never submit and read, so we don't know how normally you should consume that. So this kind of thing is very hard to do if you don't have smart meters. if you don't have smart meter, what we can do is to use the smart meter data to see more accuracy, the level of usage in this region. That's the only use case we found very interesting for the customer. Otherwise, the usage of the customers of the household in the UK is well known by the industry already, not by the suppliers. And the government give us the shape and how they use the consumption by region. Any other question? Yeah?
You talked about iterative delivery using sprints, basically.
Yeah.
So I want to know, in data science, how do you classify something as a sprint? Because the processes are different, and it takes different amount of time to do one stage of work. So when it comes to like doing sprints, what should ideally be the time frame?
So this is a very good question, and also the question I really want to ask question for the lady an hour ago. It takes a long time because sometimes you see the methodology she showed about asking the right question and make sure that you have the data. By the way that our data science team is in data team, we already know that the data we've got. And we are closer. That means even if we don't know which data we've got, data scientists ask question very quickly to the data team. Oh, guys, I have this subject. I have this question. Do you have the data? It's quick because we are in the same team. And sometimes now, when they got a lot of experience in a team, they already have the answer. They already know that he got the data. So we don't have on the sprint a lot of time in each step. Each step is very quick. Each step don't take a long time. What is take long time in our area, in my business, is more after that, pushing in live and make our model live and usable in the business. That take time to make sure that the business understanding the value and make sure that they are comfortable with the output. However, all the work, the project work, we do that in 2-3 weeks. We push a project. However, there is a lot of version. We get better and better and better, and sometimes we try different way, different techniques, so we can say, okay, in this sprint, we try different model, different way to use a model.
Hi. I see inside the organization, as a data director, you are internally you're a data consumer. So how do you deal with the data owner? I mean, how you can make sure your team have the latest data, accurate data?
So I'm not sure if I understand the question correctly, but again, the owner and the organization inside my company, we are, data scientist team are in the team that running the data lake. So all the data warehousing is part of the team. That makes sense?
I understand, but your company itself is a data company. It won't let you touch the production data.
No, it's not a data company.
No, I know, but you have a lot of, let's say, customer data.
Oh,
they
yeah.
won't let you touch the production data.
Yeah.
Let's say what you're using is as kind of a replicate of your real data. How you make sure, you're doing data science on the right data.
So can you repeat the question?
Okay, a lot of companies, they have certain data. Let's say for the utility, you have customer data, consuming data.
Yeah.
They are all saved somewhere.
Yeah.
But they won't let you run your model on that part of data. Right.
Don't get it. But anyway, we have some data from our customers, obviously, not a lot, because we are only a supplier company, so we don't know all the data about, we don't know where they are living only and who they are sometimes. Because in the energy market, someone can enter in a house, is already supplied by us, and if you don't identify yourself, we don't know who you are.
We can discuss this offline. Yeah.
Yeah, of course,
Okay.
if you want. No problem at all. I'm here all the day. I think I'm run off the time. So anyway, if you have other questions, I'm here mostly of the day. So happy to have a chat if you want. And thank you very much for your time.